positive number is written in scientific notation as some number n times 10 to some power. Okay, the thing that's important is n has to be between 1 and 10. That's the thing that's important. N has to be between 1 and 10. For examples, 3 times 10 squared. This is in scientific notation. You look at this number here, 3. Is it between 1 and 10? Yeah. And it's times 10 to some power. Now what is that number? 3 times 100, which is 300. So you can write the number 300 this way. Just another way to write it. Let's do one more. Also, you might see something like this. 1.7 times 10 to the negative 3. Is this in scientific notation? Yeah, you look at that number. It's between 1 and 10, and it's 10 to some power. Doesn't matter that it's a negative power. But what does that mean? What does 10 to the negative 3 mean? Just use the rules that we just did. 1.7 is on top. All this is on top right now. But if I want to use the rules on this 10 to the negative 3, what is that going to be? I send it downstairs, 10 cubed, and this is 1.7. What is 10 cubed? 1,000. Okay? And we could do some more work on this, but I want to show you an easier rule. You guys probably already know it. So converting from scientific notation to standard notation. If the exponent is positive, move the decimal to the right that many places. You guys know this rule? What do we do if the exponent is negative? Move left. I should say, a little bit more careful. Move the decimal left. Let's do some examples. So again, let's just take the one that we left off there. 1.7 times 10 to the negative 3. Okay, when I move the decimal, how many places? You look at your exponent, you're going to move the decimal 3 places. Which direction? Left. So this is going to be, if you want, you can write your 1.7 down. Then you're going to move it to the left. 1, 2, 3. And there's where your new decimal is going to be. And then you just fill in your places with zeros. And that's all. This one you don't put a 0 here because you've got a 1 there. .2 times 10 to the 9th. Yep. Yeah, the answer is 0.0017. Okay, so write 1.2, and you're going to move the decimal 9 places to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9. Fill in all these with zeros. And if we separate these, we can rewrite this with commas, 0, 0, 0, comma, 0, 0, 0, comma, 0, 0, 2, comma, 1. So that is 1,200,000,000. Any questions? So a convenient way to write very small numbers and very large numbers. Now the thing that we need to know, though, is doing calculations with scientific notation. So really all we need to do is a couple of products. Suppose we have a times 10 to some power times b times 10 to some power, other power. Well, they're not hard. All you do is you multiply the first numbers. So this is going to be a times b, and this is going to be times 10. Now what do you think I do with these exponents? What's our rule? If I'm multiplying things with the same base, what do I do with the exponents? Add them. Times 10 to the m plus n. Let's do an example. Suppose I have 3 times 10 to the third times 5 times 10 to the negative 7. So this is a number in scientific notation multiplied by another number in scientific notation. My rule says what? I just multiply my a and my b. In this case, I'm multiplying 3 and 5. So this is going to be 15 times 10 to, now what do I do with these exponents? Add a 3 and a negative 7, so that's going to be negative 4. Now is this number in scientific notation? Why? What's that? Because it's bigger than 10, right? So I need to do one more thing here. I want to write it in scientific notation, so I can write this as 1.5 times 10 to the, now let's think about, what did I do with the decimal? I moved it to the left, so if I wanted to move it to the right from here, I'd have to multiply this by an extra 10, so I think this would be to the negative third. So I moved it to the left, then I added 1 to my exponent. Let's see if I did that right. Writing this out, this will be 0.0015. Move the decimal 1, 2, 3, 4 places. Write this one out. This would be also 0.0015. I moved it over 3 places. So I know I didn't explain that one very well. I don't know if that'll come up in your homework or not. If it does, I can talk about it some next week. Your homework may actually allow you to leave it in this notation. We're going to do one more thing, quotient, with scientific notation. So if we have a times 10 to the m over b times 10 to the n, well, just using this rule, what do you think I'm going to do? I'm going to divide a and b times 10 to the, what's our rule for exponents for the quotient? Subtract. So the top minus the bottom, so m minus n. We'll do an example. Suppose I do 8 times 10 to the fourth over 2 times 10 to the third. So my rule says just take the first number, a over b. So what's 8 divided by 2? 4 times 10 to the 4 minus 3 is, so it's just 10 to the 1. What is 10 to the 1? And so this is going to be equal to 40. So I never spent a lot of time on scientific notation. It's really just these two rules. Okay, they're easy to do. You just multiply the first two numbers, and then you add the exponents of m or of 10, or you divide the first two numbers and then subtract the exponents. Homework for this one. This is 3.2. 5.2, yeah, sorry. Let's do 45 through 59 hard. So that's only 8 problems. And it's just like the examples I did. All right, last page of notes, last section. We're going to get out early today. If you want to stay and work, kind of like the flipped classroom, I'll be happy to help you get through some problems before you leave today. So this is 5.3, polynomials and polynomial functions. Okay, we're going to start off with some definitions. So a polynomial is a single term or a sum of terms in which all the variables have whole number exponents. Okay, so let's look at some examples. X squared. This is a single term. The variable x has a exponent of 2, is 2 a whole number? What are your whole numbers? You'll need to know that, right? 0, 1, 2, 3, things like that, right? So this is a polynomial. What about x to the 4th plus 3x squared minus a 2x plus 3? Okay, so one of the things to note is, and I talked a little bit about this the other day, this is a term. Anything separated by addition or subtraction are terms. 3x squared is a term. Negative 2x is a term. And then 3 is also a term. We call this 3 here without a variable, though, we call it a constant term. So does this match the definition? Is this a sum of terms? Yes, so this is just, all these terms are connected by either plus or minus. Remember, minus is still a sum, just summing the opposite. So this is a sum of terms in which all the variables have whole number exponents. Is that true? So this variable has a 4 for an exponent, this variable has a 2, this variable has a 1, this variable, what's the exponent variable here? No. Well, the exponent for the 3 is 1, but what's the variable? Well, not 0. So we want to think about it. Can we write this as x to the 0 power? Right? If I wanted to write a variable here, x. So my x is my variable. If I wanted to write it in, I could write it in as x to the 0. What is x to the 0? 1. So this would still be just 3, right? So I can write it in if I want to. We say that the degree for it, well, I haven't done degree yet. So yes, this is a polynomial. Jumping ahead. One more example. What about x cubed plus x to the negative 2? Is this a polynomial? Well, it's a sum of terms But is negative 2 a whole number? No. So this is not a polynomial. Another thing that you can do, I'll add to this definition. Let's just rewrite this as x cubed plus, now this x over x to the negative 2. Using my rules of exponents that we just did, let's rewrite that as what? 1 over x squared. Right? So one of the things that you can add to this definition is for a polynomial, there are no variables in the denominator of a fraction. So if you use your rules of exponents and rewrite this way, then you can see immediately you've got a variable in the denominator. It's not a polynomial. Any questions? A couple more definitions. Monomial is a polynomial with one term. So it's just like the one we did before, the x squared. No adding or subtracting a bunch of terms. Binomial, a polynomial. How many terms do you think a binomial has? 2 terms. And a trinomial, polynomial with 3 terms. Okay, we also have a definition, the degree. Just a lot of language here at first, and we'll do some examples in a minute. The degree of a term. Degree of a term is the power of the variable. Variables, I should say the value of the variable's exponent. Okay? But if there's more than one variable, you add up all the values of each exponent. So let's do an example of this. Suppose I give you x to the 4th y squared plus x cubed y plus y squared. Okay? So this is a polynomial. All the variables have whole number exponents. And let's just look at the first term. Okay, so for this first term, well, let's do the last one first. So the degree of a term is the value of that variable's exponent. So we look at this term. What's the degree for this term? Just 2. We just look at the exponent 2. But then let's look at the first term. Now, how many variables are in this term? There's 2 variables, right? So in your definition, if there's more than one variable, you have to add up all the values of each exponent. So what's the degree for this term? 4 plus 2 is 6. What's the degree for the middle term? 3 plus, this variable doesn't have an exponent on it. We assume it to be 1. 3 plus 1 is 4. Okay? Well, we also have a definition for the degree of a polynomial. So notice I've got a definition for the degree of a term, and I've also got the definition for the degree of a polynomial. The degree of a polynomial is the highest degree of all the terms. So you just look at the degrees of every term and you take the biggest one. So going back to this example, what would be the degree for this polynomial? Not 4, because you look at the degree for each term. What's the degree for this one? Degree was 6. What was the degree for this one? 4. And what was the degree for this one? 2. Now the definition for the degree of the polynomial is just the largest one of all those, which is what? 6. So the degree for the polynomial is 6. And finally, one more definition, then we'll get into some using all these things. A polynomial function is a function whose rule, remember we talked about functions, something like this, right? This was the name, this was my input, and then everything over on the right hand side, this was my rule. So a polynomial function is a function whose rule is a polynomial. Pretty intuitive definition. So we'll give an example. X squared plus 2x plus 3. Is that a polynomial on the right hand side? It is. And so this is a polynomial function. What about this one? G of x is equal to 1 over x. Is this a polynomial function? No. A polynomial function has a graph that is always smooth. That is, there's no corners or jumps or jagged parts. It's always smooth and it's always continuous. That means there's no breaks. Okay? Let's look at some examples. Do you think this is a graph of a polynomial function? Remember, it's going to be smooth, no corners or jagged parts, and continuous, no breaks. So I meant for this to be kind of a sharp corner. So this is a sharp corner, then what does that tell you? Is this a graph of a polynomial function? No. Not a graph polynomial. What about this one? Why? Yeah, there's a break here. So no. Not a polynomial function. One more. What about that one? Yeah, it's smooth, continuous, so it could be the graph of a polynomial function. It may not be, but it could be. So we also need to do, we've already worked on some of these things. Let me give you some numbers. Okay, so this is a graph of a polynomial function, and we need to do something like, this was like on your last test actually, f of 2. Using the graph what is f of 2? So this 2 is my input, right? That's my x. So when I think about 2 as my x, I want to go, on the x-axis, I want to go to 2. Now what is f of 2? What is your y? So this is going to be f of 2 is equal to 0. What is f of, let's say, what is f of negative 3? So this negative 3 is my x. So I start on my x-axis and I'm going to go over negative 3. I'm going to trace this up to my graph. Now where does this meet on my y-axis? Negative 3 goes up here, and then this is going to meet on my y-axis where? Positive 3. We also need to find what values of x will make f of x equal to 3. So this is another kind of question. Now here, f of x is what? I said f of x is always assigned to be y. So we're asking ourselves, well, y is 3, then what x's will make that y to be 3? So in this case, if it's a question like this, you start on the y-axis and go, you're starting at y equals 3. Then you go over to your function and then down to get your x. So x equals a negative 3. But there's another one on this graph. If I start at y equals 3, I can go over, hit this part, and then come down here, and let's just make it even. 1, 2, 3. Or x equals a positive 3. Okay, so there's similar questions, but they mean very different things. This is asking what is the output. This is asking what is the input. Okay. So now we get to do some work on polynomials. We can combine like terms for polynomials. So first of all, a little definition. A like term is a term, or is that more than one term, that has the exact same base and exponent. Okay? Suppose we have something like x cubed plus x squared plus 3x squared plus 4x plus y. Okay, so what are the like terms in this polynomial? Yeah, so you look, so a like term is everything that has the same base, the exact same base and exponent. So you have an x cubed here. Do you have another x cubed? No. You have an x squared here, but do you have another x squared? Yeah, so you've got this 3x squared. So we can combine these because this term and this term has the exact same base of x and exponent squared. So you can think of this as maybe an apple plus 3 apples is what? 4 apples. So we can write, now I can't combine the x cubed, so I'm going to bring it down. Plus 1x squared plus 3x squared is 4x squared. Do I have another x? No, so I'm just going to bring it down. And then do I have another y? No. Bring it down. We're combining like terms. do a little bit more challenging example. 3a squared b plus 2ab squared plus a squared b plus 5b squared a, and we'll stop there. So we have to look at each term. Do I have another term that has an a squared and a b? That's not it though, right? That's it. So this is going to be 3 of these plus 1 of these is going to give me 4 of these a squared b's. So sometimes when I'm combining like terms, I'll underline. This is just a way for me to keep track of what have I added and what have I not added. I underline those to let me know that I don't need to worry about them anymore. I've already combined them. Now look at this term, ab squared. Do I have another term that has an a and a b squared? What about this one? It has an a and a b squared, but what's worrisome about it? They're switched, right? But that doesn't matter, because remember, we can write this term 5b squared a. This means 5 times b squared times a. What do we know about multiplication? We can switch them, right? 2 times 3 is the same thing as 3 times 2. So I can write this as 5 times a times b squared. Now do you think I could add these two terms? Yeah. So I have 2 of these plus 5 of these. This is going to give me 7 of those. A, b squared. And we can't combine any more terms, so we're done. Any questions? I'm sure you guys have done a lot of this already, but I want to make sure that I at least go over it and I impress upon you these sections on exponents and polynomials are so important, because we're going to be using these coming up. So two more things we're going to do, and then we'll be done. We can add polynomials. X squared plus 3x plus 7 plus an x squared minus 2x minus 7. So this is a polynomial in parentheses plus some other polynomial in parentheses. To add them, it's easy. Just drop the parentheses and what do you think we're going to do? Combine like terms. So x squared plus 3x plus 7 plus an x squared. And notice here I've got a minus 2x and then a minus 7. So I just dropped the parentheses and wrote everything down. Combine your like terms. So x squared plus an x squared gives me 2x squared. A 3x minus a 2x, just an x. And then a 7 minus a 7, 0. So we're done. Easy enough. Last one. Now this one can be tricky. Subtracting polynomials. So what if I do x squared plus 3x minus a 4 minus an x squared minus a 4x plus 7. That's right. The thing that we have to remember is to distribute the negative first. And basically all we're doing is changing the signs of the polynomial that we are subtracting. So I'm going to keep my first polynomial. I'm not doing anything with that one. It's still going to be an x squared plus 3x minus 4. But then when I distribute the negative, this is going to be minus times a positive. This is going to be a minus x squared. Negative times a negative is going to turn this into a positive. And then a negative times a positive, that's going to still be a negative. So you just change the sign of every term in the second polynomial. This one becomes negative, this one becomes positive, this one becomes negative. Now we can combine like terms. So if I want to write it down, x squared plus 3x minus 4 minus x squared plus 4x minus 7. So like terms, x squared, and then a minus an x squared. 0x squared, right? So we don't have to worry about it. You can kind of think of them just canceling out. 3x plus 4x. 7x. Negative 4 minus 7. Negative 12. Negative 11. Any questions? Okay, that is it for that section. Section 5.3, I guess I can put it on this paper. I just gave you 8 problems in section 5.2. Section 5.3, we'll just do '61 through 1, 2, 3, 4, 5, 6, 7, 8, 9. 61 through 79. Odd. I think that's only about 10 problems. I just gave you 8 problems in 5.2, just 10 problems in 5.3. But I did give you a lot in 5.1 because I know from my experience all those rules of exponents can get tricky and you really need to practice those. Okay, so we're finished up.